Hello everyone, welcome to DevOps Summit Canada 2022. I am Arkadev Ghosh. I am working as a DevOps architect in data consultancy services for BFSI Technology Advisory Group. Today, I am going to discuss how DataOps is helping to govern new data management strategy using hybrid cloud architecture. Why DataOps? Data management has become one of the most crucial pillars for businesses to survive in today's world. Businesses are accelerating the pace of their investment in data because they recognize the strategic value their data provides. By becoming data-driven, businesses empower their decision makers to make better, more confident decisions, and these decisions lead to higher return on investment and shorter time to value. Many organizations are also facing new challenges in terms of data management, data security, data analysis, data interpretation because of the increased volume of data. That's where DataOps is grabbing the spotlight. The new methodologies are being looked upon as the key players in transforming the data management processes and even extend functionalities to enable hybrid and multi-cloud management system. It is bringing the speed, flexibility, resiliency to the data analytics. Now, what is DataOps? By definition, we can think of DataOps is a lifecycle approach to data analytics. It uses agile development, DevOps practices, and statistical process control to orchestrate tools, code, and infrastructure to quickly deliver high quality data with improved security. Let's look at the DataOps functional architecture. In the left side, we have mentioned data sources. Data sources flow in from the left and pass through transformations to generate reports and analytics for users or customers on the right. In the middle level, leave all the tools of the trade like raw data, data engineering, filtered data, data science, data visualizations, data governance, and many more. Tools and platforms can exist in the cloud as well as on-premises. Most large enterprise data architectures have evolved to use a mix of both. They will prefer the hybrid architecture. It contains support for environment creation and management. This enables separate development, test, and production environments, which in turn support orchestration, monitoring, and test. Also, the DataOps platform integrates several other functionalities. In the bottom, you can see there are storage and version control, history and metadata, authorization and permission, environment and secrets, also DataOps matrices and reports. Now, what are those platform indicates? So storage and version control. It manages changes in artifacts, essential for governance and iterative development. Like for an example, Git, Docker Hub, etc. History and metadata. It manages system and activity logs, authorization and permissions. It controls accesses to environment, like for an example, auth0, environment secrets, role-based access to tools and resources within environments. For an example, the security, like using Vault, Hashicorp Vault or Ansible Key Vault, you can use that thing. DataOps metrics and reports. Internal analytics provide a big picture assessment of the state of the analytics and data team. We call this as a dashboard. We can use various tools for that reason. Now, environment creation and management. We can treat our infrastructure as a code, be able to create places for the team to do work with all the required hardware, software, and test data sets we need. Orchestrate, test, and monitor. As the pipeline are running, orchestrate all the tools involved, test and monitor, and alert if something goes wrong. Now, here we'll discuss how we are actually implement DataOps. Let's consider one business scenario and we'll demonstrate that scenario, though it is a very small use case, but still it's have a fun to have a deployment on that particular business scenario. What we are going to do, let me explain the business scenario first. Here we are collecting vehicle telemetry and wants to use event hubs to rapidly ingest and store the data in its raw form, then do some processing in near real time. In the end, we want to create a dashboard that automatically updates with new data as it flows in after being processed. What we would like to see on the dashboard are various visualizations of detected anomalies like engine overheating, abnormal oil pressure, and aggressive driving, using components such as a map to show anomalies related to different cities, as well as various charts and graphs depicting these informations in a clear way, so that we can understand how data we can get the business insight from a particular data. Let's have a look at the real-time streaming data processing architecture. In this scenario, we are using Azure Event Hubs to ingest streaming vehicle telemetry data as the entry point to a near real-time analytics pipeline built on Event Hubs, Azure Stream Analytics, Azure Synapse Analytics. Let's look at this diagram. So we are injecting data to Azure Event Hub first. Then Event Hub will aggregate the data with the help of the stream processing. We are doing the streaming processing through the stream analytics job. Then streaming analytics job sends the data to Power BI to represent those data, and as well as we are sending the same aggregated data to Azure Synapse Analytics for further business analytics run. In this scenario, as I mentioned, we are using Azure Event Hub to ingest streaming vehicle telemetry data as the entry point to a near real-time analytics pipeline built on Event Hub, Stream Analytics, Synapse Analytics, and Power BI. Let me show you the console, Azure console. Let's implement this scenario first. Then we'll talk about what are the key parameters to implement on DataOps, key benefits of DataOps, and how we are governing the data. Let's jump into the Azure portal. We can use numerous tools, but for my own convenience, I am using here Azure Cloud. So it can be any public cloud or any open source tool you can demonstrate for DataOps activities. This is my Azure portal. For the sake of my own convenience, I have already deployed ARM template to provision all the resources. What I have done, I have already created those resources. Like you can see here, Event Hub. We have created dedicated SQL pool. We have created Synapse workspace, storage account, and stream analytics job. Let's first go to the dedicated SQL pool. What we'll do here, I'll check whether it is in a running status or it is in paused mode. It is already in it is already online mode. So we don't need to start again. Let's go back to my resource group. I'll go to the Event Hub. Now I'm configuring my Event Hub settings. This is Event Hub. I've already created my Event Hub namespace. within my event hub namespace. Telemetry is my event hub. What I'll do, I'll create shared access policy, because we are ingesting data to event hub from our devices. Let me create my policies first. Creating read policy. Listen. It will create the read policies. Once it is done, it will show the status of my policy, whether it is successfully created or not. Then I'll create write policy. It will send. Once it is done, I'll note the connection string. It will be required at the time of integration with the devices. I'll copy this connection string primary key for my future reference and pasting in my notepad. I'm keeping this handy for my demo. Let's go back to my resource group. Now I have already checked my dedicated SQL pool. Event hub I have already configured. Let's go to Synapse Workspace. Why Synapse Workspace is required? Because I'm going to create a table within the dedicated SQL pool of Synapse Workspace. It will take some time. It is loading. It is asking me to log in once more. It is taking time now. Yeah, here it is. Let's go to the data. It is still not coming properly. Yeah, here it is. Now it's loading. I'll create a table within dedicated SQL pool, so that I need to go to the SQL database. So within that database, I'll create table through SQL script. I have already kept it handy in my notepad. Let me copy that script. Yeah, I'm going to create a table, dbo.vehicle averages. Let's run. Query executed successfully, it is showing. Let's check the message. Yep, it's completed successfully. Let's go back to my resource group. Now, what I have done so far, I've already configured my event hub. I have my dedicated SQL pool is in running status. I have created one table within Synapse Workspace. under the dedicated SQL pool. Storage account is already created. Now I need to set up my stream analytics job, which will do the stream processing. In my stream analytics job, what I'll do, I'll first configure my storage account settings, because I am using here dedicated SQL pool. To hold that table, we need a storage account. Select blob storage ADLS Gen 2 from my subscription. I have already verified my storage account details. Let's save it. Yeah, it is done. Now I need to configure the input of this stream analytics job as well as the output. So my input is Event Hub. I'm selecting my Event Hub from my Azure subscription. I'm going to use existing Event Hub. My Event Hub name is Telemetry. Then Event Hub consumer group, I'll use the default one, existing one. Let me choose the authentication mode as a connection string. Then I'll use the policy name, existing policy. What is the existing policy? I have already created read and write policy. For input, my read policy would be required. Let's save it. Once it is done successfully, I'll set up the outputs. Let's go to the outputs. What are the outputs in this scenario? Power BI and Azure Synapse Analytics. I'll first choose Power BI. Let me take the details of Power BI. I've already mentioned the parameter details here. So I'll do manual settings. Group workspace, I'll come later. Let me choose the authentication mode first. I need to authorize my Power BI first. Let me authorize with my Power BI user details. Once this authorization has been done, it will reflect in the portal. Yeah, it is showing my details. Power BI, Orkodev 11 course. Yep. Now I need to give the group workspace. What is the group workspace? I need to go to the Power BI. I've already logged in my Power BI. I need to go to the workspace. So under the workspace, I'll get this group ID. This is my workspace. This is my workspace. So I'll choose this as a group ID. This is the group ID. I'll paste these. Under the group workspace. Now authentication mode is user token, dataset name. So I need to create a dataset which will reflect in the Power BI. Let's give this name auto vehicle anomalies. Then the table name, I'll choose alerts as my table name. Let's save this information. Yeah, my Power BI has been configured. Let's choose another output, which is Azure Synapse Analytics. Select Azure Synapse Analytics from my subscription. Authentication mode, SQL Server authentication. Username, I need to give the username. This is my username. Password. And the table details. I've already created this table through SQL script, and this table has been created within the dedicated SQL pool. Let's save these details. So I have already configured Power BI alerts and Synapse as a part of output stream. I've already configured the input stream, which is event hub. Now I need to write the query, which will do the data aggregation. Once the data aggregation is being done, then it will pass the data to Power BI, as well it will send the data to Synapse for further data analytics. You can see here, event hub is reflecting as an input, and Power BI and Synapse both are reflected as an output. I've already created my query. Let me copy that and paste to do the data aggregation. Once the data aggregation done, then it will send the data to Power BI as well as the Azure Synapse. We copy that. This query will find out the data anomalies from the input streaming data, which is the vehicle telemetry details. Let me save the query. Is saved. Now I have to execute this job. Let me trigger the job first. This is our stream analytics job. This job will do the data processing. Once the data processing has been done, then it will send the subsequent output parameter like Azure Synapse. For visualization purpose, it will send the data to Power BI. Yeah, it is in starting. So very soon it will be in running status if the job is working fine. Let me wait for this job status. So in the meantime, so we need data, right? So we are already configured the middle part, the streaming data processing, post that the data visualization, and also for the data analytics at your Synapse, but we do not have the data source. We need a data source. So for this demo purpose, what I have done, I have already installed one transaction generator. Through that transaction generator, I'll generate the data. This is my transaction generator. So I need to configure that. I need to connect with my event hub first. This is app settings.json file. We'll easily understand how we are doing this integration. Here we have mentioned the event hub connection string. So we already set up our policies when we have configured the event hub. Here is the job. It is in running status. Let's go back to my notepad. I have already pasted my event hub connection string. Here it is. We copy that. We need to paste here to connect event hub with my stream analytics. I hope it is fine. Let me save that. Let me trigger the transaction generator. As I am using Windows system, it's only a exe file, so I have to execute that exe file. This is the transaction generator executable. I'm generating the data now. Karima, can you please stop the recording? So here it is the data. So we have generated the data through transaction generator. So every 500 events, it will send again. And the data ingestion is happening into the event hub. Then my stream analytics job will process the data. Let me go back to my resource group. So it will take some time to process the ingestion data through stream analytics job, and eventually it will reflect into the Power BI dashboard. And the same thing happen with the aggregated data. We'll send the aggregated data to Synapse Analytics, because we have already created a dedicated table within the dedicated SQL pool. So those aggregated data will be stored over there for further analytics purpose. So I'll go back to my presentation, and we'll again come back after some time so that we can verify the visualization part as well as the what kind of aggregated data we are getting within the Synapse Analytics. Here in the background, you can see that we are already generating the data, and the streaming data is being fed into the event hub. Now I'm going back to my presentation. Let's understand how we are going to implement DataOps. These are the I can say 7 pillars to implement the DataOps within the organization. The first one, add data and logic test. If you make any change to an analytic pipeline, how do you know what kind of things you have introduced that will not break anything? So automated testing must be needed. It ensures that a feature release is of a high quality without requiring time-consuming manual testing. The idea in DataOps is that every time a data analytics team member makes a change, he or she adds a test for that change. Testing is added incrementally within the addition of each feature, so our testing gradually improves and quality is internally built in. In a big run, there could be hundreds of tests at each stage in the pipeline. Next is use a version control system. There are many processing steps that turn raw data into a useful information for stakeholder. In our scenario, we have seen that to be valuable, data must progress through these steps, linked together in some way with the ultimate goal of producing a data analytics output. Data may be pre-processed, cleaned, checked, transformed, combined, analyzed, and reported. Conceptually, the data analytics pipeline is a set of different stages implemented using a variety of tools. For an example, ETL tool, data science tool, self-service data prep tool, reporting tool, visualization tool, so on and so forth. The stages may be executed serially, may not be. It may be executed parallelized. The pipeline is deterministic because the pipeline stages are defined by scripts, source code, configuration file, algorithms, parameter file, container, etc. All of these items are essentially nothing but a code. So code controls the entire data analytics pipeline from end to end in a reproducible fashion. Branch and merge. Proper branching and merging strategy can be a major productivity booster for DataOps pipeline because it allows teams to make changes to do the same source code files in parallel without slowing each other down. Use multiple environment usage. It ensures non-production environments that mimic the production environment are available. Builds and deployments are run and tested on the non-production environment before production push, so that we can ensure nothing will break down in the production. Reusability and containerized code. Another productivity boosting method for teams is the ability to reuse and containerize the code. Parameterized pipeline processing. There are several cases when the data pipeline needs to be flexible enough to incorporate different runtime conditions. For an example, which version of the raw data should be considered? Is the data directed to production or testing to increase development velocity? These options need to be built into the pipeline. It helps you to design the data pipeline for reuse. Monitoring. One of the most important aspects. Monitoring. Your pipeline should be observable. So every operations needs to be alerted for any error occurrence. You can respond to feedback quickly and have a process for quickly addressing issues as they arise. There are different types of data pipelines: value pipeline and innovation pipeline. Why we call value pipeline and innovation pipeline in DataOps? The data factory takes raw data sources as input and through a series of orchestrated steps produced analytic insight that create value for the particular organization. That's the reason we call this as a value pipeline. The DataOps automates orchestration and using the statistical process control the quality of data flowing through the value pipeline. The innovation pipeline is the process by which new analytic ideas are introduced into the value pipeline. So eventually, it's a combination of value pipeline and innovation pipeline, every DataOps pipeline. How DataOps ensures the data governance? There are 5 key pillars for data governance: data availability, data integrity, data security, data usability, and data quality. Data availability, it ensures the data is accessible and ready for easy consumptions. Data integrity, DataOps make sure that data qualities are retained across different platforms, regardless of how it is stored, converted, transformed, and viewed. Data security. Security, we are putting security in every aspect within the pipeline. So safeguards in place, including classification according to its sensitivity, storage. It will apply different storage policies, produces and ensure the proper data protection. So data remains secured when it is in rest or when it is in transit phase as well. Data usability. it is clearly visible that the data is structured, documented, and it's tagged. The data quality, one of the key aspects of using data ops is to maintain the data quality. It ensures data is correct, consistent, and clean. We are bringing different kind of tools to maintain or to remain the data as much as clean possible. Now we'll see what are the key benefits we are getting by introducing data ops. As I mentioned, we are bringing the automations. We are using automations to do our work, which will eventually reduce errors, because automated orchestration reduces process variability and errors resulting from manual steps. Input, output, and business logic tests at each stage of the workflow ensure that analytics are working correctly. Collaborate and coordination. DataOps provides team with the compelling direction, strong structure, supportive context, and shared mindset that are necessary for effective teamwork. It ensures the quality of data. Transparency. Pipeline status and statistics are available through messages, reports, dashboards, KPIs. It maintains the security. Platforms are secured with access control. Data in transit and data in rest must be audited and meet company security standard. Data democratization. Data can be made available to more people, even users outside the data team, who bring contextual knowledge and domain expertise to data analytics initiatives. Now I'll go back to my deployment. Let's check what kind of a data we are getting through our stream analytics job. Let's go to my Power BI. Just taking time to load. Yeah, we have created the auto vehicle anomalous data set. We can see, right? So let me create the report. We'll understand what kind of a data we have generated. This is my table alerts. Let me create a map. Choose the city as the location. We'll take the aggressive driving. Here it is. If we are focusing this data, then we can easily understand. We are collecting the vehicle telemetry data. From that data, we are finding the insights. From which city we are getting the details for each and every city. What kind of a aggressive driving is happening over there. Let me create another dashboard. Tree map. I'm going to create a tree map. Let me take transmission gear position. Consider the engine temperature. So when we are, what kind of a gear positioning we are using and what kind of a temperature we are finding. Let me take the average of this data. Here it is. Let me focus this data. Average of engine temperature by transmission gear position. So if it is a 7th gear, then we are getting the engine temperature is quite high. If we are in low gear positioning, then the temperature, you can see, it's reduced. So we can see how data is being visualized through Power BI. Let me go back to my Azure console. Now I will check whether we are getting the aggregated data in our dedicated SQL pool. We have already created one table within dedicated SQL pool. This is the table, TBO.vehicle averages. Let me execute the query. The query is executing. Yeah, we're getting the details. Average engine temperature, average speed, and the snapshot. We can do the further analytics with this data. Let me take a look at this data from a chart. Yeah, we can see the correlated average engine temperature with average speed, and every 2 minutes interval, it will give you the snapshot. So with the help of the DataOps pipeline, we can get the insight of business data. I hope you have enjoyed today's session. Thank you for being here.